Okay, this is lecture 6 for 498, and it's mostly about you. I need to talk about a few things first, so I'll do that, and then we'll get into your detailed design presentations. I had a bit of a talk with Michael F. earlier about not having much done, and that's true, right? We got a bit done, we've got some parts, and we now have all parts. But one thing Michael suggested that I'll try and do next time I take a cohort through is get the teams to order their parts at the end of semester 1. So by the time you come back, at least, all the parts are there, right? So you can start the semester with toys, right? So we'll see. But I was having a look. Let's see if I can bring it up. And courses. I should have downloaded them before. Oh well. I was having a look at, say, the fall 2019 teams and their presentations. Just download those ones.
Were these ones recorded?
That's a good question. I don't think they were. So I've only really gotten into recording stuff and running tablets and stuff since COVID in March 2020. I didn't want to do that. I wanted to extract. Here it is there. What's that one? Now, is there a way? I did it before. I've forgotten how to upload. There we go. Upload. And the detailed design presentation. I'll just go with one of them, the universal remote. So this was done by Ryan Neninger and I've forgotten Jojo's family name, and who else? Bray Jackson. Yeah.
I've also seen the Honeyberry one.
Yeah. So this is their estimates, I suppose. So this was their presentation from 2 years ago, right? and you'll see that maybe not a lot has been done. Maybe the main thing that I've got to figure out with all of these is about half, maybe 75% of the projects have done software, have done hardware, and have had to do mechanical. And a lot of the mechanical piece that people have done is has been 3D printing. I don't know why that's not. Anyway, let me just go through it this way. Right, so there's a project overview, success criteria, system behavior, more detailed, and that was, I thought that actually worked before. Well, apparently not. Design update. So they talked of, they were building a universal remote control that they could control lots of stuff with, and they were looking at different ways of doing it, right? So one of the things they eventually got around to doing is doing a 3D, or they had it by this stage, they had a design for their 3D printed case. And you can see they had various LEDs, sensors at one end. Right. And there's a cost update, schedule update, lessons learned, conclusion. And they had a few shipping delays. They did all their own shipping, and even though they did that, they had a problem. They were wanting to ship some apparently hazardous material, and that causes other paperwork and various things. There was something about, I've forgotten. There was something about the way they were supposed to do something. It might have been in KiCad, or it might have been something else, and they did it one way, and it made the circuit completely not work. And then they read the fine print on, I think it was KiCad, and they figured they'd done something wrong. They redid it the right way, and then it all worked. But it was something. So, right, that was pretty much it. There's not a lot to that. I would like all the teams to be a little bit further along. And like I said, one of the things I think I'm going to take up Michael on his suggestion of trying to get stuff ordered earlier. So that's where we are. We're gonna have a look at your design presentations. There's one thing though that I've realised that I should have talked to you about before, and I haven't, and it should have gone into this detailed design, and it's not going to. It's mostly on me, but I do want to talk about it quickly. So at least two of the groups are talking about doing an app. And there's more to doing an app than doing the embedded code. Right? So one of the things you've got to do is think about what screens you need. And I think next week what I might do is talk about what screens. It'll be too late for the detailed design document. I may try and put together a video about it before then, but you really do need to think through what pieces need to be on each screen and where each screen navigates to and from before you start coding. With React Native or with Xamarin, it's easy to make screens, but then it's what do you make? And that's the problem piece. This set of screenshots or wireframes I call them, was made by a thing called balsamic mockups, and it aims to look sort of like an app, but not really, right? You can tell it's sort of a cartoon version of the app. And the reason for doing that is if you make things look too real, your boss will say, oh, you've done it already. And you haven't. Right? So you want to keep it black and white. You want to keep it cartoony or simple or obviously not real. And anyway, the aim is to think about the app before you go in. This one is this is actually the customer view. So this is just a web page view of, I don't know whether any of you have seen the take a number thing that I use for labs, where you take it's like a deli counter ticket numbering system. What I'm doing is, I still want that available on the web for the customers, but I want to put together an app for, this is a mobile view of the web, but I want to put together an app that the manager will use, and that will put a bit more security. At the moment, the thing is completely wide open to anybody who has the URL. It's not a particularly secure URL even. I want to lock it down so that the management piece is only available on the app. Anyway, I will talk a little bit more about how to do that next week, and we can, like I said, it should have been in what you're presenting today, but it's a bit late for that now. Just a reminder, that 10% product piece, I'm going to be looking at your success criteria in today's presentation and in your detailed design document due next week as effectively a rubric for what you produce at the end of semester. Okay, so we'll see how that goes. And quick update on the numbers. Parking automation, by my calculation, is about SPI 0.9, about 59% done. Home security drone, about 73% done, 0.94 SPI. And smart fridge update, again, that number is significantly lower because it doesn't include last semester, 40% at 0.84. Maybe I haven't updated it correctly, but in fact this backing hasn't changed since I first put it up, so it's not an indication of where those numbers came from. And now I would like some presentations. I don't know, Michael, whether you want to go first?
Why not?
Yeah, could do that. So everybody should have 2 of these sheets. I want you to put your name and, well, not the people who are in the home security drone. I want you to put your name and the name of the team that you're reviewing. So that should give you that. And yeah, we can sit up there, even though it's going to be mostly recorded. It's got to be manually started. So if you want to go, so first up we have the home security drone.
Good morning, class.
You guys ready?
You ready?
Good morning, class. This is the Home Security Drone team. My name is Bright Obeng, and with me are my team members Michael Frederick, Carl Mitchell, and Jacob Noah. We're presenting to you today about a detailed design document. For this presentation, these are some of the things you should expect. Our introduction, our block diagram update. We'll talk about system description update, which includes the drone, the camera module, the sensor, the application or the software. We also talk about schedule update. We'll also talk about the update we made to our budget, the challenges or the lessons that we've learned from this project. We'll talk about the success criteria, which is the functional requirement and non-functional requirements. And then we'll give you a conclusion about the whole presentation. And then finally, some references.
According to a study on home safety and security published by SafeWise on August 16, 2021, roughly 40% of United States residents have no home security measures in place. Despite Americans believing that crime is on the rise, home protection measures fell by 6% between 2019 and 2020. This is concerning because approximately 63% of all burglaries in 2019 occurred on residential property. Of the other roughly 60% of U.S. citizens that are protected, the most common form of protection is cameras, followed by dogs, then firearms, then live monitoring services. Our project aims to provide homeowners with an alternative drone-based security system to protect their property. One of the biggest reasons that we chose to do this project was due to the limited field of view provided by typical mounted security cameras. These blind spots could provide criminals with windows to evade detection. By making our camera mobile through the use of a small drone, we hope to mitigate these blind spots and provide a broader scope of protection. Another reason for doing this is the cost. Purchasing multiple security cameras can cost hundreds of dollars, and you may still have unprotected areas. At the time of this presentation, we are on track to develop our system for under $150, although as development continues, cost may increase slightly. We believe this low cost, in conjunction with the wider scope of protection, will give homeowners an alternative security system to protect their property. Having a drone patrol your property is not very common these days, but let's be honest, it's really cool.
This is our current block diagram to date. The difference between our previous block diagram and our current one shown here is within the cell phone device block. As you can see here, we have removed the create an account feature. This was done due to the complexities that would have been involved in making this feature operate. If we had more time though, this feature would have remained. The rest of our time will be distributed across the remaining features as shown in each device block. The cell phone device block contains the following features: drone control, trigger alarm, and contact authorities. The drone controls feature enables homeowners to control the drone using the cellular device. The trigger alarm feature notifies the homeowners that motion has been detected in a particular area. Lastly, the contact authorities feature enables homeowners to quickly call the local police station. Now within the drone device block contains the following features: patrol inaccessible areas and record media. The purpose of the drone is to patrol areas that would otherwise be inaccessible by stationary cameras. In addition, the drone will be able to record media during the day and the night. Now, in the motion sensor block, there's only one component: detect motion. The sensor's main role is to detect motion whenever an attacker is sensed. Now, all of these device blocks are connected to the application through Wi-Fi connection. The following few slides will discuss the subsystem description. Within those slides, we will introduce the drone, camera module, sensor, and application software subsystems.
For our drone subsystem, we had originally chosen to use a pre-built drone kit. However, it became a concern that we would not easily be able to customize both the hardware and software to accommodate our needs. This led us to choose the PowerDay DIY quadcopter kit. It includes most of the necessary hardware components needed to make the drone fly and can also be easily retrofitted with some of our additional components. Now let's take a look at the included components. The frame is made out of carbon fiber. This lightweight frame provides us with enough surface area to be able to mount our hardware without being too heavy to lift off the ground. The kit also includes 4 brushless motors that will be used to generate lift. We will need to test these motors to ensure that they can handle lifting the drone with the additional weight from our modifications. If not, we may need to upgrade them. Also included are 4 electronic speed controllers, or ESCs. This is the electronic circuit that acts as an interface between the drone motors and the pilot's commands. The kit also includes a CC3D flight controller. This board is the stabilization hardware. It runs the LibrePilot firmware. LibrePilot will allow us to program the drone to do what we want, such as auto level, autonomous takeoff, autonomous flight, and autonomous landing. Next is the Matic Mini Power Hub, which distributes power from the battery to the motors. It also provides DC outputs for powering cameras, sensors, transmitters, LEDs, etc. And finally, the kit comes with extra propellers in case some get damaged or broken during testing, which most likely they will.
The AKK Micro FPV AIO camera module is an all-in-one camera that has an antenna, button, and LED display. This module will be mounted in front of our drone and is needed to record media when the sensors detect motion. The module is 4.7 grams, which is ideal for our drone system. In addition, the module has a 120-degree field of view and a resolution of 720 pixels. The PIR motion sensor proves to be the best solution for detecting motion at a reasonable distance. The sensor is inexpensive and has a low power consumption. The sensor uses the BISS0001 integrated chip, a great choice for hobbyists not wanting to spend a fortune. In addition, the sensor has 2 adjustable dials that controls the delay time and sensitivity range. The sensor has 3 pin connections, one for power, ground, and data. Now, the data pin will connect to a ESP8266 Wi-Fi module, which will connect to a program that will notify the user that motion has been detected. Now, the program that will be used is called If This Then That. This program enables different devices to interact with each other via Wi-Fi. This slide shows both the PIR sensor on the left and the ESP8266 Wi-Fi module on the right. Now, if we take a look at the PIR sensor, there are 2 orange dials. One controls the delay time and the other controls the sensitivity range stated in the last slide. The application we intend to create allows homeowners to either take control of the drone, signal the drone to fly autonomously, or when necessary, direct homeowners to the local authorities with a click of a button. Implementing these features will be difficult, however, we have developed 2 possible solutions. Solution 1 involves having multiple applications perform these desired functions. However, this is an inconvenience to homeowners and time is very essential, especially if a criminal has been detected. Now, solution 2 involves modifying pre-programmed software to implement our goals, but this assumes that the software is programmable. Without a doubt, there's a solution that will accomplish our needs. However, more research must be conducted.
This is our schedule update. So far, everything is going according to as planned. We're currently presenting our design document. We will make necessary changes in the future if needed to.
As you can see in our budget total is $135.67. The parts that include is a 3D printer, our quadcopter, sensors, our camera, and our computer ESP8266. Few major changes were made to our design that has changed our budget from our previous created one. Our first difference was the drone. We realized that making any changes to our previous DIY drone would be much more challenging than a newly discovered one. The construction of the first drone didn't offer us many places to be able to add the camera or features we would like to. Another large change we made are the computers from Raspberry Pi to ESP8266. The thought behind this was that the new computer has much less weight to it, which surpasses our problem of weight distribution on the drone. Moving on to our challenges. The pandemic has created a lot of challenges in itself in general. The ability to not be able to freely meet as we would like under state regulations, such as classrooms are restricted to certain uses and labs have limited resources. A challenge we will continue to face is having our items work with one another. The coding and hardware aspect will be continuing challenge throughout the project since this is our first hands-on experience. The team has also been struggling to figure out our meetings to communicate from our busy life schedules. Most problems we've been facing is trying to figure out when everyone is free to discuss, since half work in the day and the others work at night. A few lessons we learned so far through the project is to always order extra parts, because as new engineers trying to fix a real-world problem causes us to break a few items. As well, we discovered that constructing the drone always causes a problem even with weight transfers, so the motor themselves can support it for flight. On top of things, there's never too little research that we find each day. There is so much knowledge to know about each component, it becomes a lot to learn.
For our success criteria, we group them into functional requirements and non-functional requirements. For the functional requirements, the first point is the system shall connect to Wi-Fi. We first decided to use Bluetooth for the connection, but after much research, we found out that Wi-Fi would be the best option because it has a longer range of connectivity than the Bluetooth, which makes it better. Our next point is the system shall patrol inaccessible areas. There are areas that the system cannot access while it's stationary. So once it takes flight, it is going to patrol and access these areas. The next point is the system shall detect motion. Motion detectors will be placed at inaccessible points for the drone. So once these motion detectors detect a motion, they will send a signal to the drone. And the drone will also in turn send the signal to the user. Our next point is the system shall contact authorities. We've decided to design the app in such a way that there's going to be a button that you can just hit, and then signal will be sent to the authorities for them to come check what is going on. So once the drone detects motion and send a signal to the user verifies and find out there's something suspicious going on, all they have to do is hit that button and it will contact authorities. The next point is the system shall mount on a rechargeable station. we will have a rechargeable station for the system. So once the system is done operating, it will go back to the rechargeable station and then recharge. And the last point is the system shall trigger alarm. We will have a trigger alarm button in the app that we're going to design. So once the system sends the detection to the user can decide to hit the trigger alarm button, which will trigger an alarm to scare whoever is intruding the place. For our non-functional requirements, the first point is the system shall operate via rechargeable batteries. The system will come with rechargeable batteries that once it runs out, it goes back to the charging station for it to be recharged. Our second point is the system shall record after detection. Once motion is detected and signal is sent to the drone will then take flight and start recording for a maximum of 10 minutes. Once it's reached the max, it will go back to the charging station. Our next point is the system shall fly for a minimum of 10 minutes. The system is designed in such a way that it can fly for a very long time. So once it starts flying around, it can go past 10 minutes. And the last point is the system shall not exceed a maximum weight of 10 pounds.
So, to summarize, we believe our drone-based home security system will be beneficial to homeowners as it will be able to patrol inaccessible areas that cannot be covered by mounted cameras. With the cost coming in under $150, this is on par with the cost of some of those same cameras. However, it provides more protection. The hardware needed to develop this drone includes carbon fiber frame, 4 motors, electronic speed controllers, flight controller, power distribution board, camera module, PIR motion sensors, and Wi-Fi module. Software needed to develop the drone includes LibrePilot, which is needed for drone control and stabilization. We will also be developing an app for controlling the drone and receiving motion detection alerts. App development will be done using React Native. At the time of this presentation, we are right on schedule to have a working prototype by December of this year. We are also under budget at approximately $135 out of the allotted $150. Finally, some challenges that we have had to overcome include conflicting schedules of group mates, time management, and the COVID-19 pandemic. Despite all this, we have learned so much through this development process and are very confident that we have the ability to create a functioning prototype within the allotted time. Thank you all for listening and enjoy the rest of your day.
Okay, thank you very much. Does anybody have any questions? I have a few, but
Obviously, it's going to be outside. So how would it handle the weather, essentially? Because it needs a clear takeoff, so it would be exposed.
Well, we haven't gotten that far, to be honest.
Actually, yeah, I never even thought about
We, that's something we're gonna have to work with
That's
once
a
we
good
actually
question,
assemble it
actually.
and start testing it. We'll have to figure that out.
Michael, did you have
Can you go back up to the components part for a second? Before I ask the question. So, when it's recording, is there an onboard storage system, or is it getting streamed directly somewhere else and being served?
That's a good question. It may be streamed to the app, so we might have like a storage system on the app.
Database? Okay.
Yeah, that's a good question.
So how are you?
So you raise your hand.
Or, how exactly are you going to be able to control it?
Use your phone.
Oh, it's going to be on the app?
Mhm.
Yeah.
Oh, okay, cool.
Yep.
And then I guess, if it's already in its charging port, how would it actually detect the motion?
The sensors will be placed separately, and then the sensors will, when they detect motion, they'll send an alert to the app, at which point the user will be able to either take control manually or send it out autonomously, and it would take off.
I was wondering if the camera is on a gimbal or is it fixed mounted?
It's going to be fixed mounted.
Okay.
And where is the drone is going to be installed? In the roof somewhere? Where is the drone is going to be installed?
The charging station, I mean, that's up to the user. You can put it wherever you want. If you want to put it in a garage, if you want to put it inside, if you want to put it outside, it would be up to the user.
But in matter of case, if the drone detects something going on around the house and the owner is not around, he just receives text message.
Mhm.
So the drone have to fly out and take, recording of what's going on.
Right.
If in the garage, how is gonna come out, or it have to be like somewhere where it's flexible to fly itself right away.
So most likely outside then.
Yeah, it makes sense to have it outside.
Mm-hmm.
Instead of like that's something that we just have to talk more about.
And if it's outside, how is gonna be resist to the weather? Like how is it gonna be protected?
It's going to have a weather resistant casing.
It's not that.
Yeah, we're 3D printing that.
Okay. So when it's flying by itself, can it recognize like trees and like even the house? Like if it's just flying around, what if it just like crashes right into a tree or something?
Yeah, I believe with the Libra pilot, you'll be able to set up some sort of like collision detection with it.
Okay.
We haven't gotten that far. We just got the drone in today, so that's something we have to play with. But we were looking into the Libra pilot, and that should be a feature that's in there.
Gotcha. Thanks.
Yeah, that's actually an interesting question.
Mhm.
So the drone itself doesn't come with sensors, I don't think, does it?
Mhm.
So how do you know what sort of sensors you need to do that?
I believe the Libra pilot software comes with that option, but we might have to buy additional components.
Right.
But we definitely have to look more into it.
That's excellent. I had a question. Do you know with this drone what the flight time is? And then you know with this drone what the flight time with the camera and extra sensors and that sort of stuff might be?
The base kit on Amazon, I believe, said like 15 to 20 minutes of flight time. However, obviously, once we add more stuff to it, it'll reduce. Again,
Which is
we
why
just got it, so we
yeah.
have to put it all together and test it to know for sure.
Because we were gonna first assemble and see how long flight times were, and then compare and contrast, and then basically the plan was to find a bigger battery that exports out the same power source. Because I think a lot of it is in 5 volts, I believe, and a lot of batteries like to push out 2.5 or 3 volts. So we're trying to also figure out that factor.
So can you just go to your success criteria, the non-functional. Okay, so the system shall fly for a minimum of 10 minutes. One thing I'm going to be looking for is that you've actually tested that and you have data to back it up. Okay. Obviously you can't have it now,
Right.
but by the end of semester you have to say, okay, I don't care that much whether you made the 10 minutes or not, though it would be better if you did. I care whether you tested, whether you could say, this was our success criteria, this is how well we did. Okay? You should have what the weight is, right? And you might want to split the system is the drone, the sensors and everything. You might want to split out the weight by each little piece.
Okay.
And yeah, I think that was the main point I made there. You had on the app software slide. Wherever that was. You did that.
Those are your slide, Mike. About the app.
Yeah.
Yeah, that
Yeah.
was. So, I didn't quite get the difference between the two solutions. Could you explain that a little bit more?
So we have different functions, right? We have the user could fly the drone manually, that's one function, or they could fly the drone autonomously, I guess. And then also the sensor would have to send back, the data back to the app. So we might be able, so the first solution would be, we might be able to produce that, but it have to be done with multiple softwares. So it won't be in one complete app. So that was the first solution. But with that, like I stated in the slide, it would be an inconvenience for the homeowners to have to, switch to multiple apps to, work the product. The second solution was to somehow, with the software provided by the drone, the flight controller, try to manipulate it to accommodate all of those features, but that assumes that the software could, be reprogrammed, etc. So that was the second solution.
Okay. Okay. I had a couple of one other comment. So you made the statement about costs, right? And whenever you do an engineering project, a product development project, there's two pieces that you're interested in terms of cost. There's what is the thing you're building going to cost to make once it's in production. But then the other piece is what's often called the NRE, the non-recurring engineering cost. And that is the cost that it takes to actually do the design. And it doesn't necessarily include the cost. It probably includes the cost of prototypes and that sort of stuff. But the thing you're interested in usually in a product development is how much is it going to cost to make to deliver to the customer. The other discussion that you have then after you know what the cost to make is what are you going to sell it for, and that's a sales and marketing question. Any other questions?
Is the camera module on there?
You said it's a camera module.
Yeah, I just want to see what it was.
Oh, okay.
Okay, I think we're done. Thank you very much. So if I could get the audience to fill in your feedback sheet, please. Also, and I'll collect them all at the end. So who's up next? So how do you want to do it? Do you want to? How do you want to do it? Do you want to?
I can just. Who signed in on that computer there?
This is Michael, I think.
I'll just sign into mine then, and then.
Yep, we can do that.
I'll have to download it.
I don't remember seeing it.
I'll just sign out.
That was like 20 minutes ago. With the question.
We're just starting with questions first.
Not
Right? We just need minutes, right?
you need two.
Okay, there you go. If you don't mind, I will be right back.
Yes.
Oh, Sean Lynch. You know, it's pre-recorded.
Mine are too.
Is that mouse pretty sweaty already?
I just hate hearing my own recorded voice.
Yeah, yeah.
I hate that.
Scary up there, man. Just looking back at all these ugly mugs.
At least we're not actually presenting these stuff
Right.
over ourselves.
Yeah.
I'm sorry. I didn't mean to do that.
More than this morning.
Yeah, just throw it right in there. No, we don't have it. We don't have any talking for it.
We just filled in.
I mean, there's a lot to think about.
I mean, I can't even get it to open. So
I mean, we're good with that, so we can go on fire. Top right.
yeah, we got this.
want to get us out. Wow.
So as you can see,
Presentation is so long and beefy. It's just a hand.
We're just like, all right, we're gonna build a 3D face.
Come on, you.
Be gentle with them. Should definitely not.
She's not responding.
so as you can see from our smart fridge upgrade,
This is how far we've gotten with the project.
I'm glad I'm not the only one who has computer hanging issues.
no, it's just usually the school computers.
Eric working on heater, so
Yeah, it's
all the problems.
This might take several minutes. Okay.
Wow.
Huh. How does it do that?
Hello, everyone. Welcome to our presentation of the Smart Fridge upgrade. I'm Michael Paloka, and my partners are Eric Burston and Anthony Musumeci. So, in the current world we live in, many household devices are being adapted so they have smart features where you can connect to them with your cell phones, or they have interfaces on them directly that you can use. What we've noticed is that these devices are relatively expensive compared to their counterparts which don't have smart device features. So our goal with the Smart Fridge upgrade is to provide a cost-effective way for consumers to have that same experience but not have to go and buy a new refrigerator. So on to prototyping. We currently do not have a working prototype, but we just received the hardware parts last week. So we will be hoping to have the hardware side of it running pretty soon. So for our hardware device prototype, it's based on a Raspberry Pi system. It's powered by a 26,800 milliamp hour rechargeable battery. It has two Raspberry Pi camera modules that will be attached to the ribbon cables to the Pi module. And attached photo resistor will be used to activate the cameras when the fridge door is open, and that will take photos that will be uploaded to our domain. We also have a companion app prototype. This will be developed using Swift for iOS. We plan the app to be an easy-to-use interface for the consumer. It will allow them to access most of the most recent images taken by the SFU device. It will allow them to create lists for shopping needs, and it will also allow them to make a list of their current inventory of what's in the fridge. Through the first half of the project, up until where we are now, we've learned that time management is essential. At the beginning, we believed that we overplanned for this project without actually realizing we had to execute it in a timely manner. Although we knew that we could add extra features to advance our product, we simply could not find the time to do that. We also learned that our overall budget is pretty good compared to the provided budget by Professor Kutsukus. We were given a budget of $150,
and our total came to $102.16. And down the line, this will help us if we need to replace any of the parts because of accidents and unforeseen problems. So on to the block diagram. Our first input is when the refrigerator door opens. This activates the light sensor system. So what goes on here is the photoresistor is activated due to the light entering the refrigerator. This connects to our Raspberry Pi, which then activates the camera system. When the photoresistor goes off, the camera modules will take photos of what is currently inside the refrigerator, and this will be uploaded to our storage system. Another input we have is user inputs to our touch interface, which is our app system. This app system will work directly with the Raspberry Pi. Through the app, it will be connected to the wireless internet, to our domain, where it will have access to the photos taken by the Raspberry Pi. Our Raspberry Pi system also has onboard storage where lists can be saved to and backups of photos can be kept as well in case there's a problem with the domain. Now onto our interfaces. Our end user interface is going to be the companion app for iOS that we're designing. This will allow the user to create lists, look at photos that have been saved to the database. There will also be an optional touch interface on the refrigerator where if the user has a tablet that is available that they do not necessarily use every day, they can Velcro it to the front of the fridge and use the companion app and use that as an interface to make lists when they need items. Some of the physical interfaces include the connection to the camera modules on the Pi, the connection to the rechargeable battery, and the connection to the Wi-Fi network.
So our success criteria will be based on functional and non-functional requirements. Our functional requirements are as follows. The system shall keep an inventory of food product. The system shall have 2 cameras which allow for pictures to be taken of fridge inventory. The system shall have a connection to a secure domain through the user's home network. The system shall connect to the domain through an iOS application, and the system shall transmit data through a Bluetooth adapter. Our non-functional requirements are as follows. The system shall be able to run off of a rechargeable battery. The system shall be able to withstand standard refrigerator temperatures. The system battery shall last at least 12 hours on one charge. The system cameras shall take pictures of the inventory when the refrigerator door is opened, and the system shall be able to accommodate for any form of refrigerator. Referring to our success criteria, our system behavior is as follows. The system will be attached to the inside of the refrigerator in a case capable of withstanding refrigerator temperatures. This is so we can ensure that the fridge looks as normal as possible without any extra wires or components hanging out or mounted on the outside. Attached to the system, the Raspberry Pi system, there will be 2 cameras, a battery, photoresistors, and a Bluetooth transmitter. The system will be activated by the light entering the refrigerator, hence the photoresistors, triggering the cameras to take pictures of the product inside. These pictures are then sent to a domain through the Bluetooth transmitter. The following diagram shows a very basic performance of our system behavior. The 2 C's on the refrigerator over here are the 2 cameras that will be installed inside the refrigerator. The system right here will contain our Raspberry Pi, the battery, the Bluetooth transmitter, and the photoresistors. When the refrigerator doors are opened, the light entering the fridge will trigger the system to send a signal to the cameras to take a picture of what's inside the refrigerator. These pictures will then be sent wirelessly over to a domain. This domain can be accessed through the app that we create for mobile devices. An optional feature for our system is adding a tablet on the front of the refrigerator door, which will then be able to access the same app as the mobile application. The locations for each of the components inside the refrigerator are simply a prototype. We do not know exactly where in the fridge everything will go yet, but this seems to be an option that will capture the most inventory inside the refrigerator. Shown here is a schedule for the second part of the capstone project. Up until now, we have finalized our detailed design presentation, and we will be getting ready to start prototyping later next week. As of now, everything is on track.
So a part of our budget, we have parts that were given to us by Professor Kutsukus, which would be the Raspberry Pi 3D Model B, the soldering kit, and the Samsung tablet we have at home already, and the refrigerator that's been brought in. As for parts that we had to order, would be the Raspberry Pi camera module case, which came out to $25.98. Our domain name, which we had to buy separately, that came out to $11.99 per year. Our Raspberry Pi wireless adapter dongle came out to $19.99. Raspberry Pi rechargeable battery that came out to $37.99. And our Raspberry Pi photoresistor module that came out to $6.31 for a total cost of $102.26. At this point in the project, we are pretty much focused on getting a prototype to be able to test our theories and our functional and non-functional requirements. We hope to have a fleshed out design for our final project within the coming weeks. Our overall SPI is out of range if we're compared to the document that Kutsukus keeps, only due to missing entries from the previous semester. While putting that into consideration, we consider ourselves on track to meet our goals. As for references, the first three hyperlinks that you can see are used for our data, our comparison costs from our competitors to us. And as for the bolded hyperlinks, those are all of our parts. And the very last one is our picture of the fridge.
Thank you.
So I want the $8 one. What's the $8 one? That's DIY smart fridge only costs $8 is your third reference. Why am I paying $102 for it?
You're paying for the experience. And we're gonna throw T-shirts in there too.
Does anybody have let's go.
So, what is the purpose of the domain name again?
So that's what the app is gonna connect to, and that's where the pictures are gonna be stored, kind of in like a cloud storage.
Oh, so is it like a database? A cloud
Yeah.
database?
Yeah.
It's being able to access the photos from your fridge on your phone, and that domain acts as a proxy to get it to your phone.
Any questions? Is this just for a fridge or be used in the freezer as well?
We are making it so it is used for the temperatures of a fridge. Obviously it's possible, but it's not something we're totally looking to do, because freezers are varying in design. Like you can have a chest freezer, so it's not exactly something we were trying to do.
So what mobile platforms will this app be?
Right now, it's iOS.
Only Apple? No Android?
Right. Well, you had a Samsung tablet, but that's not wireless.
Yeah.
Wait, what was that?
You mentioned
Oh, yeah, that's right. We were gonna.
Just imagine you didn't see that.
So I think
It's optional.
Originally, what we were going to do is, it wasn't going to run the companion app. It was going to be a separate list, so you can keep track of exactly the contents in your fridge. Or say you need to make a grocery list, you can have it on there. Obviously, we're going to have the option to have it in your phone as well, so that's going to be obviously for your Apple or iOS.
Any other? Yep, you're fine.
Earlier than today's presentation, I heard your system is going to have the owner able to see the expiration date of the item in the fridge when they're going to be expired. And today I don't heard about it. It's still part of your
We had to remove it due to the time constraints because it's a lot of data. You have to have the original items already in the system. So we decided to cut it off to be able to make it in time. Obviously, if we have the extra time, we might actually add on the feature back. But as of right now, we plan to not fall through that one.
What about the recall? You had mentioned that before, like if a product is recalled, are you still including that, or?
That would be part of
That's part of
the
the
standard
feature.
Yeah.
Gotcha.
Why do you have two cameras?
One on the left, one on the right, so that way if there's like an item behind something, kind of catch it on both sides.
Yeah. So it'd be stitching the photos together to be able to make a cohesive picture where you can actually get the full inventory.
Yeah, because the last thing you want to do is be at the grocery store, check your phone, and see something maybe behind something, and you don't know if you have it or not. Kind of destroys the purpose.
What's the field of view on those cameras? Can you see everything that's in there?
We haven't tested it out yet,
Okay.
so we don't totally know. But
I get that. We're in the same boat.
But we
That's another reason why we went for two.
Yeah.
Just to make sure the field of view is
Exactly.
as much as we can get in there.
being able to stitch it together, I think it would make up for whatever problem.
So it seems like the Raspberry Pi is the brains
Yeah.
of this entire project?
Yeah.
So where would the Raspberry Pi be? Would that
So-
be inside the fridge?
Yeah, so this is just a prototype design, but the orange square that says SIS, that's going to be the case containing the Raspberry Pi, the photoresistors probably, the wireless transmitter, and the battery pretty much. So everything's going to be in a case, and depending on the fridge, we'll put it somewhere inside there.
And the case would be able to withstand the temperature?
Yes, yeah, that was one of our functional requirements to make sure that it can withstand the temperatures.
Is the camera gonna be like bird's eye or top down view?
In this angle, it would be
Is it
top down
like
view,
top-down?
but this isn't a permanent like fixed spot that we're
Gotcha.
going with.
Yeah.
Cause like what if they were like shells and they were like non-glass shells so you can't see
Yeah.
through them either? So
Yeah,
how
it-
would that work?
It varies on fridge. Our fridge only has one shelf, so if we just put it in the corners, it's going to be able to capture
So
everything.
basically like different fridges have like different camera systems?
Right.
Yeah.
We wanted to make our project flexible for any type of fridge, so the cameras aren't just in a fixed spot. It all depends on what we have in front of us.
Are the batteries easily swappable? Like if it's
Yeah,
dead?
Yep.
it's just a micro USB connector.
Yep.
So you guys, so it's more of a statement, but you guys should consider making an app for Android, and I would really
We just chose that because we all have iPhones.
Right.
It's fairly straightforward.
So, it's just with the image storage thing, just a suggestion, just to make things a little simpler, you could use like an Amazon S3 bucket. That's just basically a cloud drive.
Okay.
And you can use your domain and point it to the appropriate cloud drive easily enough.
Gotcha.
If you've got access to the DNS outputs on the domain name. Are you actually sure that the battery will work in the fridge? Yes. Yeah, the temperatures for the battery, I think, was 0 Fahrenheit. Oh, really? Yeah, so. Okay, that's good. So the reason I ask is one of the first senior design project, catchment projects that I looked after was the forestry department at the place I was at was wanting to get a sensor that they could take out into the middle of nowhere, throw it into the forest, come back 2 weeks later and had temperature measurements every 5 minutes. And they were looking at doing this in a really, Australia not that cold, but this particular place they wanted to measure had got really cold. And our biggest problem was, we wanted to get down to, from probably about -30 Fahrenheit, something like that. And the biggest problem is, at the time, none of the batteries would work out at that temperature. So we had, for 2 weeks, so we had to get a, I think it was a gel cell type to do it. So it's, batteries are better.
Other than that, I think our biggest challenge is going to be fighting off condensation.
Yeah.
From the parts. So,
Yeah, with wings.
other than the temperatures, I think that's going to be the hardest thing.
Any other questions? Okay, thank you very much. And I'll get parking automation symbol in there. That's okay? Oh, you got a...
Yeah, I was just gonna have this on the side, just for me to look at.
Okay.
It's just a little bit of lighting for my note cards.
Yeah, you can move it there.
Yep.
And just a reminder to fill out your feedback on the smart fridge update. And I'll get all the sheets at the end.
We should get a half off because they can't support your phone. Is it what? Should get a half off because they can't support your phone.
iOS exclusive.
That's it. That's the point.
Apple race only. Let's do it.
Exclusive deal with
We're going for the family. Oh, yeah, man?
He's actually my godfather. We find it out on the download.
Up.
Go for it. That's the best. The highest number, so I would pick it.
Cool.
On to something. On to something.
I'll go right there. Cool. Alright. We're good?
Very good.
Sweet. Alright, so I'm part of Parking Automation Group with Michael and Fahim, and I'm Kyle. The passion that we have behind the parking automation system is I want to make sure that everyone is able to get to a parking spot quickly. When you're trying to go in for an interview for a job, or even mundane things like dropping your kids off at school, whatever it may be, the last thing you want to have to do is have to hunt around for a parking spot for 10 minutes at a time, 5 minutes even, because that can make you late. Those kinds of things can make you late. And parking automation, the point of it is to keep you guys from having that extra time tacked on to the end, right? Nope, I tried to do it on the wrong thing. So with the parking automation, it reduces your headaches, right? Of course, it reduces any headaches that can be resulted from being late or almost being late. We found that an average American can spend up to 17 hours a year just looking for parking spaces. That's not driving around, that's just hunting around for a parking spot, right? And that varies, right? If you're out in the country, it might not be such a big deal, but if you're in the city here in New Britain or anywhere else where parking is harder to find or you have to pay for it, it makes it more difficult to try and find parking. And that raises up those hours. This system will decrease that time, right? It'll decrease that time, it'll reduce the headaches, and it'll make it easier to find your car again, right? So how this system works, it's fairly straightforward. It uses sensors to detect vehicles entering and exiting a certain parking spot, right, parking area, and it keeps track of those numbers, and it displays them so that you can easily see how many spots are remaining in an area, and if it's worth trying to go through this parking area even before you're in it, right? So that way you don't have to look around, drive around, deal with all the parking lot traffic. It also alerts the users of parking in the area, right? Like I said, if it's at 0, you know, there's no parking spots available, you just move on to the next one. Right? So it alerts you before you go in. So our plans are currently to have this ready by December, a prototype ready by December, with an early prototype stage set in this month now. In October, by the end of October, we'll have the early prototype ready to go. And in November, we're going to finalize all our documentation. Everything will be ready to go in terms of like material documentation and everything. Yeah, that's pretty much our current timeline, super abbreviated. Let's see. So our design, as you can see, of course the parking lot enters your area, right? And so let's say we have space available in this parking spot, right? It goes into your parking lot, then the system, these sensors, are gonna tell the parking application whether or not there's any available spots, right? It's gonna reduce that by 1, and then you're going to find that space, right? Detects it, and then the sensors, we put IR sensors here. That's our main go-to, but we also are going to try some other stuff too. We're going to try ultrasonic along with that. And then it's going to tell the Arduino system, which is going to store that information, and then it's going to go right back up to our display, right? So that way you can see exactly how many spots are available. And our use case diagram, same idea. Oh, my bad. I see it in front of me, and I keep thinking I'm changing it back there. It's all good. Thank you. Yeah. Same idea, right? The driver comes in, we display the parking. He can see the parking easily. Goes in the lot. He sees, the sensors see him. Tell the Arduino that, you know, that spot has been reduced by 1. And then when he leaves, we know that space is available again, and then we record their parking space, right? When they come in, we record it. When they leave, it's no longer there. Not screwed up this time. All right, Fahim.
Okay, this is our circuit design. You could see from the first presentation, we eliminate too many devices. We make a very simple. This is part 1 of the circuit. There is another part with the software, but we will talk about the hardware first. This is Arduino. This is the LCD I2 display, and those the IR sensors, and this is the servo motor. So how it works, you see the LCD, how it's connected, very simple, to the Arduino, and this is the first sensor. When any car going into the parking lot, the sensor will send it the Arduino alert there is a car coming in, servo motor open. Once the car hit the second sensors, alert will go to the Arduino, and servo motor go back to close the gate. That is the basic circuit, how we build it and how it's gonna work. And this is the LCD display. And when we go to the software, what we're gonna have 2 codes. One code is for the Arduino, telling Arduino what to do, and the other one is for the LCD display. I will explain where is the SDA with the serial data going to a bin, and the SCL, the clock bin. And we're gonna have 2 codes. One code is for the Arduino. We write it down and tell the Arduino what to do when is in car coming in. Flag 1, that's meaning 1 car is going in. And how's the servo motor will work when each car coming in? There is a lot will go to Arduino, servo motor will open, car hit the second sensors, servo motor will close. Same thing when there is a car coming out, it will alert the sensor go to the Arduino, servo motor will open, car hit the first sensor, servo motor close back the gate. And it's very basic, that's how it's going to be, and that's all about the circuit.
All right, so our functional requirements, what's up? Damn it. Our functional requirements is, first things first, it has to, of course, give real-time data, right? It has to update constantly whenever the vehicles come or go. It has to notify the driver of unavailable spaces, right? It has to make sure that it's updated so you know whether or not there are available spaces. It has to notify the driver if there's an accident in the parking lot, right? If there's a collision or for whatever reason it's going to be more of a hassle to go in there than it's worth. It's going to notify you if it's out of service. And it's going to notify the driver of any empty parking spaces, right? You know, if, like we were saying before, if there's any empty parking spaces in a specific lot that you can use. And how many spaces there are per level, right? Those are our functional, those need to happen. So our cross-functional or non-functional is that, all right, no capacity limit, right? We don't want the program itself to be stopped by having say a 10-car capacity limit, but really that specific lot has space for 20, right? So we want to be able to accommodate as many parking lots as we can. We want to be able to send, to basically use the sensors within seconds, right? So the sensor is going to send the data to the Arduino within seconds, right? The parking system will be sensitive to motion, right? Just like the IR sensor or the ultrasonic sensor will be able to detect that motion. It'll have this one may or may not stay in here because it's a non-functional, but we're going to use a magnetic field detector, which would actually use the shadows of the vehicles to detect if it's a vehicle or a person. Which, that way, you know, if someone's trying to come in and they're obviously, you know, if it's just a normal person, it would still trip the sensor, but it wouldn't be a car. So it would be mislabeling and misreading data. And it needs a long life battery, so that way it can keep chugging along even though it's, you know, completely independent of any system. We don't want to have to basically hook it up to a computer and make it dependent on a computer, right? Or any other power source. We need it kind of internalized. All right, Fahim? Yep, got it.
So this our budget. You look at it from the first budget we have, it goes low maybe by 70% of the total cost. And that's what I was speaking before about how we eliminate our circuit, because these days the company is looking at the cost, the lower cost. They don't look about what brand and where it's made, because right now everything made by China and you got 1 year warranty annually. And this is what we have, Arduino. We got it from air servo motor and IR sensors, and we added the ultrasonic in case. We switched the IR sensors to those, and the servo motor back we have one pre-owned, anyways there we added it, we bought it, and we added in case the servo motor is 90, maybe they work better than regular servo motor. And this is the batteries rechargeable, so when we use the circuit we didn't have to hook it up to the computer and all this, just to install the code and the system and make it easy to present. And that's all about the budget.
Cool. All right, so for the schedule, for the schedule, we are moving along. Obviously right now we're doing the presentation and the documentation. and we're wrapping that up. We've been working on the we call it the pre-prototype. So before we prototype, we wanted to make a functional, kind of like a low or almost low functioning copy to prove like a proof of design for it, right? So we wanted to make our proof of design, and now we're just starting on the documentation, right? So we want to make sure that all the materials are well documented on what we're using and how we're using it specifically in our prototypes. Right, and then the next thing we're going to move on to is our material creation, right? So specifically like 3D printing, stuff like that, making sure that the system has a box or a safety device to keep it within. Yeah, housing. Thank you. And then we're going to troubleshoot it, make sure it works, test it, smash it around a bit. See what sticks around, and then we're going to document all of that. And like I said before, it'll be ready by early December. Okay. Yep.
All right, so concluding the slides, we can see that this system it helps implement parking time, just time to search for a parking space. It helps to eliminate that in real time. Project feasibility is pretty fair, as the budget is way under our given budget of 150. So that thing's around 75.
Yeah.
I would say the budget is also pretty accomplishable when accounting for what the actual system can do. And $75 to eliminate, just by one person, to eliminate say $300 a year. I think that's fair just for one person. I also believe that this project is very reproducible. After we get the final thing done and it works for us with the small amount of parts it is, I think it's very reproducible to any parking lot or any parking garage, I would say. The implementation plan is on track with the proposed schedule, aside from unforeseen circumstances that we can't account for, like COVID, for example, or one of us gets sick or something like that. The system will be using data and real-time information to guide and lead the operator of the system or anyone coming into the garage to exactly where they need to be or where they need to go. If a similar issue comes up, once again, I think this project can really tackle what this problem is with the everyday person.
Okay. All right. That's all we got.
Anybody got any questions? Eric?
Shoot.
What do you guys do about handicap spots? So like, let's say that someone checks if there's any open spots, but it's a handicap and they don't have a handicap.
So like a handicap specific spot.
Right.
Okay, that's actually a really good question. We haven't gotten there yet. That would definitely be something that would be like near the end of our prototyping, is like tacking stuff like that onto the end. But I imagine it'll have sensors specific to the lock. Okay. Right. Anthony. Whoever.
I know that you're using a metal detector to discriminate between pedestrian and car.
Yeah.
Do you guys know how far the sensitivity goes? Like, say I'm
We do.
wearing a metal bracelet, would I be able to count in the car? Or?
We do not. That was something we came up with early on, and we've still been looking into it. Currently, we're focused more on making sure the IR sensors and the ultrasonic sensors, whichever one we use, is basically which one is more effective at detecting whole objects first, and then we'll start tightening it up more and more into stuff like that. So.
I know the requirement said no capacity for how many parking spots would be
Right.
available. But at the moment, is it just one? It's only since one spot, or what's the current limit on it?
Our project will go up to 4 or 5 slots.
Okay.
I will add it up to 5 slots. this is not the issue. We could upgrade the code and I could go to 20 slot in the project presentation here, but we want to eliminate it to 4 or 5 slot. We're able, to show and present the circuit. But when we design our final, like for the future, it's unlimited.
Yeah.
And that's why we go for low cost. So hopefully, CCSU buy for our first system, so we could install around this parking lot.
So you would have an app that would tell you what spots are open?
Either way. At the moment, it's an LCD display, so there's no software application.
So it would be like at the entrance of the garage?
Exactly. Yep.
Okay.
Yep.
Okay.
It would be a physical display that you would see.
Gotcha.
I think that was a little bit misleading with I said software application. We're talking about inside the Arduino holder.
Gotcha. Okay.
The app is this part of the future, upgrade the system.
Exactly.
But we want to eliminate it and make like a low cost for the school and for us to buy equipment.
Yeah.
But for the future, this is part of the system.
Well, the problem that I have with that is then you have a bunch of people with their phone out while they're driving.
That's
to
what
the
we
parking
thought
lot.
too. Yeah.
So, I mean, I don't know if you guys have gone to Mohegan Sun. They have something similar to this,
Mhm.
where they just use red and green lights above the spot if it's open. So when you're driving by and you see a green light, you know the spot's open.
Right.
So that might be something to consider.
Oh, when you enter the parking lot?
Yes. Yes.
When you enter the parking lot, there is gonna tell you the display in the front, each level of the parking lot, how many space empty in each level. Like the first floor has 200 levels, 200 space empty. So you're gonna go to the first floor and there is 200 empty space. You don't have to go around. You will find them easy.
Yeah.
So you guys, you mentioned long life battery. How long are we talking about?
So when I was looking into them, because this is such a low power system, it could last for like months. That's something, of course, we still have to test more extensively. But with I think it was like a 10,000 megampere hour battery, it would last us a long time. It would last us probably like a couple weeks without a problem.
When we say a long time life in the batteries, that's mean only in emergency. If the light goes off, we're able to use the system for a week, 2 weeks. And that's mean long life. By the time the system will be, the power will be back on to recharge for the system.
Yeah.
Okay, that's one piece of feedback I give you with those non-functional requirements. Every non-functional requirement should have a figure, a number, which you can say is going to last
Okay.
7 days. It's going to last a month. If it's going to last 6 months, then you might have trouble actually testing that.
Right. Yeah.
Between now and the end of the year, but you could at least put the number down and then say, hey, we had it, right?
Okay.
Rather than just long life. Long is different for different people.
Cool. Thank you. Yeah.
So is this going to be in a parking lot where like the spots are literally right next to each other, just like a standard parking lot?
Yeah.
So the sensor for sensing when the car is there, is it going to sense if there's cars next to it and get triggered off of that? Because like what if someone like drives by a spot and then backs in? That might trigger the empty spot right next to it.
No. When you enter the parking lot, it's going to be like entrance to enter in.
Right.
There is a gate. It's going to open for you, allow you to go in.
Right.
When you go in, we have the first sensor, allow the gate to open. At the same time, added the number of slides and the parking lot is being occupied. That's one slide is being occupied, the gate is open. With the car, leaving the first sensor, there is another sensor in the left side.
That makes sense.
Giving the information to the gate to close.
Okay.
That's how we work in the code, to close it. When you come out the parking lot, same thing, the sensor will reduce one parking lot and send it, to the gate to open. When the car hit the first sensors, it's close the gate. That's how it's working in the code and in the response.
So you know the predetermined spots already, you're just tracking how how many cars enter and
how many cars
Exactly.
leave on the parking lot, yes.
So it's right the boundary around the parking lot rather than each.
It would be insanely inefficient to try and do each individual parking lot.
That's what I thought
or
was
space.
going on.
Yeah, that's
so
what I was
that-
asking before, how many
Yeah.
spots.
That makes a
Oh,
lot of sense.
gotcha.
That was your original plan?
Yeah.
At the very beginning?
Yeah.
Yep.
Okay, yeah.
That's from the beginning, yes. We was thinking to edit the app to let the drivers before they reach the parking lot, how many empty space there. But like we said, that's cost, it's gonna cost us, it's gonna take time, it's something. So we're looking for lower cost. These companies, they're looking for the lower cost first. When they like the system, maybe they could, ask you to upgrade for them. Then, yes, more money.
Gotcha.
Cool. Any other questions? Okay, I think we're done. Thank you very much.
Awesome. Thank you. Remind me not to do a speech with a mask on it.
Yeah, totally.
You want these collected?
Okay, so we're done. Thank you, everyone. Everybody has all their parts. Can I get the feedback sheets? Just leave them on the table here on your way out. And yeah, good presentations. I have some feedback which I'll give each team individually as well. I'm pretty happy with that. Compared with other years, that's pretty good. At least as good. Some of it is better. Which is my aim is to get me to improve you.
Did we have to do a?
I don't care, it's up to you.
Yes, so I do want a status report again. It doesn't have to be done now, but it should be done today.
I can do all of it. We already submitted ours.
Doesn't matter. See you tomorrow.
Yeah, see ya.
I don't have anything going on. You want to chill in the summer, we can do that. He wants to take it. Doesn't matter. Have a good weekend.
Yep, thanks, Sam. So, I told you I have a friend who's
Yeah?
Phil, he always been fine.
I swear to God, everybody, all my friends call me Moose.
Oh, really?
Yeah.
Cool.
Yeah, it's pretty natural. It's just a play on.
Play on
him.
name, I know. Yeah. Cool.
That's pretty cool. I don't know Phil though.
No, well, he's in Australia, so he's,
Okay, so that would make a lot more sense.
Yeah. Not that one. That one. And let's kill that. Okay, that one. Some lights on. Let's kill that.